Okay, here we go. Ready? So like I mentioned, we're going to be taking a look at sort of a review of our two-dimensional geometry. All right, here's what I want you to do first off. Okay, over in this little space that we have right over here, okay, what I want you to do is I want you to draw something that looks like that. Sure, we can call it that. And then I want you to draw a line through the middle like that. And then I want you to cut it in half like that. Okay? And then I want you to take each of these sections and I want you to break them into thirds. Like that. All right, question. If each one of these blocks is made up of a 1 by 1 dimension, how tall is this shape? 2 units tall. Okay, good. Wrong tool. Okay, so this shape is 2 units tall. How long is this shape? 6 units long. Good. How tall is this side of the shape? 2 units long. How long is the bottom side of that shape? 6 units long. What do we call it when we figure out the entire length around the shape? No, the perimeter. Okay, that's the perimeter word. So the perimeter is, if I were to take all of these and fold them out into one straight line like that, how long is that line? In this case, it would be 2 and then 6 and then another 2 and then another 6, right? And so we're looking at 18, 12, and 4, 16, sorry, okay? So we're looking at 16. Now, how many little boxes exist inside this shape here? 12 little boxes exist inside that shape, right? Okay, and we can count them, 1, 1, 1, 1, like that. Or we could say, hey, we've got 6 sets of means times in math, 6 sets of 2, or we have 2 sets of 6. Either way, 2 times 6, 6 times 2 is 12. Yes? Everybody good? Okay, what do we call that? That's your area. It's the square space inside. Now you say, okay, that's really great for an easy shape like this, but what about this guy? How do I fit squares inside of there? Well, we actually can. If we drew a triangle on a piece of graph paper and then we were able to actually calculate all the little small portions of that, squares that got cut off there, we would be able to figure out the area in terms of how many squares. There might be fractional squares that we have to add together. But the nice part about this is as math people, we come together with these formulas. And one thing that we do know is that if you take 2 triangles and you put them on edge together, you end up getting what we call a parallelogram or a rectangle or a square. So all triangles are half the area of a square, which is why you see this formula right here. Now here's our perimeter for our rectangle formula. Here's our area of a square formula. And then you can see this is our area here. Now you'll notice these little letters B and H. What do you think those stand for? Base and height. Base and height. Very good. Now, something that's super important for you to know, jot this down. Lowercase b, base, and lowercase h, height, you'll see why I'm saying that in a week or so, always meet at 90 degrees. And you will see me use highlighters and things in the notes. So if you have highlighters out and you want to use some colors or colored pencils, and I have a bunch of colored pencils up here too that you can grab at different times. So base and height always meet at a 90-degree angle, right? So that's easy here when we're trying to find the area, base and height. We did that really simple, base and height. So check out with the triangle. This is your base. This is your height because they meet at 90 degrees. So you're looking for this little square angle marker, right? That tells you the numbers you're going to multiply together. In this case, you cut them in half. You shouldn't be talking while I'm talking, right? You should be listening, focused, working. Okay. All right, now let's talk about parallelograms, right? These are our squares or rectangles that are leaning, okay? Because they're leaning, they have a triangular type of look to them, right? So we have this height that runs up and down this base. Again, base and height always meeting at 90 degrees. And then we have this guy. Anybody know what this one's called? This is the tricky one. Yeah, that's a trapezoid, right? Now, trapezoids have what we call two bases. They're the parallel sides, the ones that run like this, like train tracks. We'll talk more in detail about parallel, okay? And here's your formula for that. You're going to take the two bases and add them together. That's what you're going to multiply by the height, and then you got to cut that in half, okay? That's your formula for trapezoid, all right? I expect you to know all of these. You should be able to do all of these, okay? All right? And then we have circles, all right? Now, circles are a little weird because we bring in this thing, right? So let's delay our conversation on pi for just a minute because I do want to talk about that, but let's just do a little work here, and let me show you how I want you to model the work. Now, one of the things we're going to be focusing on in geometry is, can you set up the math problem correctly? Remember I talked to you about that the other day? And I'm going to also ask you to give me the reason, eventually give me the reason why you set up that problem the way that you did. What geometric principle are you using to set up your problem? For these questions, I want to see that you can set up the problem correctly and then come up with the answer. So for example, like this question right here, we want to find the area of all of these figures below. So in this case, setting up the work would look something like this. Area is equal to, now this is a square, right? So we would still base times height. So I'm going to do two sets of parentheses, base times height. You fill in the numbers that go in there. Okay, you should have put 8.5 and 8.5, right? And then from there, you can then calculate your answer on your calculator. And then jot it down. We're going to round our answer to the hundredths if we need to. We'll talk about that in just a second. What'd you come up with? Somebody raise a hand. Tell me what you got. Raise a hand. What you got? Yeah. 72.25. Very good. Now, super, super important. This is where you're going to lose your first points on your assessments. If you leave your unit off, okay? This is feet, and we're talking about area. It's feet times feet, so therefore it is feet squared, okay? Please do not leave your unit of measure off. That will be an immediate knockdown on your grade, okay? Got to have your unit measures. Setting up the problem, coming up with a solution to the problem. Those are two different standards that I'm going to be grading you on. Can you show me how you set up the problem, and then can you come up with the solution? Okay? Those are two different grades you're going to receive on the assessment. All right, so let's do number 2. All right? How would you set up the problem using the formulas above? Why don't you try that? Let's start with set up the problem. How I set up the problem. Now, it's okay if you wrote 1/2 times parentheses, that's okay too, as long as you understand that multiplying by a half and dividing by 2 is the same thing. It's fine. It's not a problem. I want you to show me how you set up the problem and then calculate the area. Go ahead, you do it. Did you come up with that? Yes? How many people got that? Let me see around the room. Ooh, not that many, huh? Okay, all right. Maybe a few. All right, maybe we're just not raising our hand. All right. Okay, so you're multiplying these two numbers here and then dividing by 2. Questions? Good? All right. Let's take number 3. How would you set up the problem? Take a look. Give it a shot. See how you can do. Set up the problem. All right, setting up the problem should have looked like that, right? Because we're talking about a parallelogram here, right? So we've got a base and a height. That's all we're doing. It's the area of a base and a height. So we multiply those two numbers together. And then we come up with the area is 91.59 square inches, or inches squared. Yeah? Everybody okay so far? Any questions? All right. Let's skip down to number 5. Let's skip down to number 5. Okay. What kind of shape does this one fit into? Is this the parallelogram one where it's base times height, or what is this? This is the trapezoid one. Good, right? Okay, all right. Let's see if you can set up the question the right way. Go for it. Give it a shot. Like that. Right? So it's the sum of the two bases times the height, and then we're dividing by 2 or multiplying by a half. All right, go ahead and finish it up. Correct. Good job. 368 centimeters squared. Okay. Here's what I would like you to do right now. Here's what I'd like you to do right now. Right now, I would like you to do 6, 7, 8, and 10. We're going to leave the 2 circle ones for a minute. I want you to do 6, 7, 8, and 10. Okay? 6, 7, 8, and 10. You go ahead and do those. 6, 7, 8, 10. Ready to go. So take a look and see how you did. Good. Questions you want to talk about? Okay. Shh. All right, go ahead, man. Okay, so the question is what did you get wrong? So did you get the setup of the problem correctly? Or was it just in the multiplying? Okay, all right. So this is, you can see we've got 4 90-degree angles, right? So that means that any one of these are going to be a base and a height in the sense that we've got 2 sides that meet at 90 degrees. So we just take those 2 measurements and multiply them. That's our rectangle. Make sense? All right. Any other questions you want to talk about? We good so far? Okay. Let's go deep. Ready? Let's dig a little deep right now. Okay? I want to talk about circles for a few minutes because we're going to be working a lot with circles, and there's a lot of really cool things about circles, but I'm going to show you something about circles. You may or may not know this, but let's take a little look at something here. So I'm going to come up here to the notes, and I want you to just kind of hang with me for a second. Okay? So let's talk about these 2 measurements. The C, what does the C stand for? That's the circumference. What is the circumference of a circle? The whole length, so all the way, so we were to walk all the way around the circle and we were to measure it like with one of those little wheelie measury thingies, right? Then we could come up with the length around the circle. Then, of course, the area would be all of the distance inside the circle, right? Now, when we were watching our introductory video the other day, the little Khan Academy video on Euclid's Elements, he used an example when he was talking about, like, well, you know, people may have noticed back in the day, like, you know, what's the relationship between the distance around a circle and the distance across a circle? And it's not the same for every circle. And right, he was talking about that. Well, let's talk about that, okay? So what does it look like when we take and we run this line through here and we put a D on that? What's that word? Diameter, right? Okay. And then what is it when we take half of that distance from the center of the circle out to the edge? That's the radius, right? Okay, good. So we got this language down, right? And then what is this funky little hoodie right here? Pi. What is pi? No. I didn't ask you what the value of pi was. I said, what is pi?
The ratio of the circle, right?
It is a ratio of the circle. Yeah.
How much you can divide it into.
Okay, so let's talk about that for just a second. Okay. What I want you to do is I want you to draw a little swoop like that. Okay. And let's talk about for a second the circumference of the circle. So the circumference of the circle is 2 pi r, right? Now I want you to notice this right here. 2 pi r is the same thing as pi d because 2 r's make 1 d. Is that legit? Now, hey, when I was asking you about stuff the other day, like properties of math, and people were shouting out substitution, right? This is substitution for you right here. I'm going to take the 2 times r, and I'm going to substitute it with a d for diameter. Now, If I wanted to figure out what pi is, I could solve this equation for pi. Okay, we just did solving equations. That means isolate the variable by itself. Well, pi is a variable. We can replace a number for it, so it's a variable, right? So if I wanted to isolate pi, if I wanted to get pi by itself, what math would I need to do? What's going on the pi side of the equation right now? There's multiplication, right? Pi is being times by diameter. So how would I undo times by diameter? Okay, so then I'm going to start where I need to cancel, right? And if I do something on one side of the equation, the what property?
Equality.
What, do you say the whole name?
Property of equality.
What kind of property of equality? There's 4 of them.
Division.
The division property of equality forces me to come over here and do that. So I'm going to rewrite this. What we're saying here then is that pi is the ratio of the circumference, the distance around the circle, to its diameter. That means that's true. There is some relationship there. It does exist. Now let's take a look at what that relationship is, okay? So here's what I want you to do. I'm going to use my little liney tool here for just a second. All right, so to the best of your ability, I want you to draw yourself kind of a straight line-ish thing right here, okay? So draw yourself a little straight line right there. And then down this end, I want you to put a point. And down this end, I want you to put a point, okay? Now this line right here, I want you to imagine, is like if you were wearing a belt and then you undid your belt and you laid it out in a straight line. That's the circumference of the circle. Okay, you see it? I just took the belt off and I stretched it out flat. Okay? Now, check it out. This distance right here is a straight line, right? Okay? Now, we can take and we can break up, put a point right there, and put a point right there, and then put a little teeny point right there. We can take this distance and we can break it up into 3 equal segments and then a little bit left over. And those equal segments are the distance across the circle, the distance across the circle, the distance across the circle. Well, and then you got this little weird piece right here, which is about 14% of the distance across the circle. So then we have D plus D plus D. What's D plus D plus D algebraically? No. If I had an apple plus an apple plus an apple, what do I have? 3 A's.
Like the 3 and then 40% 1/4.
Oh, 3 D's plus 14% of a D.
3.14 R.
Oh, no, 3.14 D. Is what?
Pi.
No. Is the circumference of the circle, right? That's what the belt is, right? So that's what the belt is, right? Okay. So if I divided this D off here, right? I could get rid of the D, yeah? By moving it to the other side. And then I could use substitution. C divided by D is the same thing as, that's where it comes from. That's one way to prove it. Another way, like, and we can write that same sort of thing on here, like put a point here, and then put a point about here-ish, and then put a point about here-ish, and then put a point about here-ish. And then you could say this is D, and this is D, and this is D, and this is 0.14 D right in there. That's one way to understand the circumference of a circle. It's 3 diameters and then 14% of a diameter combined together. That is the relationship. And that exists for every circle. So any set of points that's equidistant from one point in space, that we call a circle, that's the definition of a circle, you can take any of those and mathematically it will all work out exactly the same to be 3.14-ish% of a diameter. 3 diameters and 14% of the fourth diameter. Does that make sense?
Yeah.
See it? Okay. All right. Humor me just a little bit. I want to hurt your brain. Okay? All right. Let me hurt your brain just a little bit. Okay? I'm going to show you a video right now, and it's gonna hurt your brain a little bit. Okay? But listen, here's the deal. This is going to have math in it that you don't know yet. But you'll see a lot of substitution. You do know substitution. You'll see some things that you'll know, but this is going to have some math in it that you don't know. Yes.
Wow.
But in May, you will know it. And in May, you will be able to go back and watch this video and go, oh, dang, I actually understand it. But let me hurt your brain for just a second, okay? Give me just a minute, and I'm going to cue this up.
This is pi, but how did Archimedes calculate it? Here's a formula that is derived from Archimedes' method that approximates the value of pi. We can input any positive integer for n, and the result will give us an approximate value of pi. The higher the value we input for n, the closer we get to pi. So now, why does this equation work? Around 200 BC, Archimedes devised a method for calculating pi by method of exhaustion. First, we create a circle with a radius of 1/2. Now remember that the circumference of a circle is equal to 2 pi r. So with a radius of 1/2, the circumference is equal to pi. Next, inside the circle, we inscribe a polygon, and we increase the number of sides repeatedly. What we can see is that every time we increase the number of sides of the polygon, the more it resembles the shape of the circle. Specifically, the perimeter of the polygon approximates the circumference of the circle. So let's derive a formula to calculate the perimeter of the inscribed polygon with an arbitrary number of sides. We know that the radius is 1/2, and we'll call the center of the polygon point A with points B and C as two vertices. Next, with line BC and point A, we construct line AD such that it is perpendicular to line BC. And incidentally, point D bisects line BC. So triangle ABD is a right triangle with sides A, B, and C, and an angle called theta. Line DC also has length A. Now, in order to find the perimeter of an equilateral polygon, we must find the length of one of its sides. Using trigonometry, we know that sine of theta is equal to the opposite side over hypotenuse. Looking at our right triangle, we can see that the side opposite angle theta is A, and the hypotenuse is 1/2. So A over 1/2 simplifies to 2A. Next, looking at one of the sides of the polygon, we can see that it is actually equal to A plus A, which simplifies to 2A. Therefore, the length of the side of a polygon is equal to sine of theta. The perimeter of an equilateral polygon is defined by the number of sides times the length of a side. We will simplify by replacing the number of sides with n so that the perimeter is equal to n times side. But we know that side is equal to sine of theta. Therefore, the perimeter is equal to n times sine of theta. Finally, we must find what angle theta is equal to. If we connect all the vertices of the polygon to the center, we can see that each individual angle is equal to 360 degrees divided by the number of sides of the polygon. And theta is just equal to 1/2 of one of those angles. So theta is equal to 180 degrees over n. Therefore, the perimeter of the polygon is equal to n times sine of 180 degrees over n. So looking back at our circle with a circumference equal to pi, we can understand why increasing the value of n approximates the value of pi. because the perimeter of the inscribed polygon with more sides approximates the circumference of the circle.
Okay, so now we are back at our discussion of circles. We have a little bit more thorough understanding of what pi is, and then we can use that in our calculations to find area and circumference. So let's come down here and let's find the area of this circle. So we want to know if we had squares and we were able to measure those, what would be the area of this circle? Well, what do we have first? This measurement of 26 yards. This is a radius or a diameter? This is a diameter. Okay, so in order for us to do the area of a circle, it's pi r squared or pi radius squared. We've got to come up with the radius of this, right? So what's the radius of this circle? Which is 13 yards, right? 13 yards. But when we're doing our calculations, we're not going to squeeze all the measurements in there. We'll just leave the measurements for our answers. Okay, so how would you set up this problem? Well, you would go area is equal to pi times r squared. So that would be your setup for the problem. What number am I going to write in the parentheses? 13. Okay, now I want to show you something, okay? Because as we move forward into our three-dimensional geometry, this is the most exact answer you can get, and this is actually the answer that I want you to have on your paper, which is this. Area is equal to 169 pi yards squared. That is the most accurate answer that you can get. Why is it accurate? Because pi is an irrational number. It's not actually 14% of that diameter. In fact, that value goes on forever and ever and ever. It doesn't repeat and it doesn't stop, right? And so if we multiply 169 times 3.14 or 3.1415 or 3.14159, or you use the pi button on your calculator, depending on where we round that number to, we're going to get an approximation. I do want you to get the approximation just so that you know how to do it. So in this case, why don't you get the approximation and round to the nearest hundredth? Okay, so get the approximation by taking 169 and multiplying it by, if you have a pi button on your calculator, which if you have a reasonable scientific calculator, you'll have a pi button. That's the easiest way to get the best accurate answer. Okay, if not, then you can use 3.14159. So if you don't have that, I would say the closest you're going to get would be to use that. That's a good use of pi right there. That'll get you pretty close to the pi button on your calculator. All right, so approximately this is 530.93 yards squared. Okay, so this will be the answer, but I do want you to calculate on all your homework today. I want you to calculate the approximation just so you get the feel for doing it. But this is how we will leave our circle answers in terms of pi. Okay? Questions? Make sense? Okay. We're not going to find the circumference here. We could. Same sort of way. All right, we would leave our circumference in terms of pi as well. Okay, let's go down here and talk about number 9 then. Why don't you set up the problem for number 9 the way you think it might work? Go ahead, give it a shot. Do that. Okay, yeah. So this is what you should have had, something like that. 17 is your radius, right? And then you've got your pi radius squared, and then we're cutting that in half. All right, you come up with the values in terms of pi and the approximation. Go for it. Round it to the hundredths. Give it a shot. Look, let's see how you did. You should have gotten that right there. How many people got 144.5 pi and the approximation correct? Both of them. Pretty close. Pretty close. You got how get the approximation. Did you get the pi part right? Yeah. Okay. All right. And then the approximation, you're just going to take your 144.5. You're going to multiply by your pi button, or 3.14159. 14159. 14159.